So, good morning, everyone. Let's get this thing rolling. I received a number of email requests saying, "Whoa, could you please go over some more problems in 3.4?" And so I think we might be due for a review day. We'll see how it goes. Now, I think those are primarily from my other section, but still, I'm guessing there may be some questions from this group too. So let's get started with some questions. Are there any 3.4 questions that you would like to go through? Okay. Anyone? Wow. So with the other group, that was evidently more of a need than with you. Let's see. I'm trying to watch my messages too. Yeah, I'm a little bit out of sorts here. My phone died on me, so I'm using alternate electronic means this morning. No questions. Okay. So those desperation requests were only from the second.
13, 15, please.
Okay, 13. All right, number 13. Let's look that up. 13. So the cube root. Yeah, let me just grab that. So these two. All right. So those are the two problems we want to take a look at. All right, number 13.
Yes.
So we've got the cube root of 6x squared plus 1. We should probably consider doing some rewriting here. So we could certainly write this as to the 1/3 power. And now when we take the derivative, we need to think outside the in. So on the outside, you're going to take the power rule, bring the power down, reduce the power by 1, and then we have a chain rule. We have to multiply times the derivative of the interior, which would be 12x. So that's the end of the derivative. Now it's just a matter of, can we simplify this? Well, 1/3 times 12x is 4x. Making a little mess here. So we've got 4x, and then this thing goes on the bottom. So how do we write to the 2/3? The fact that it's negative, I moved it down. Probably the best way, I don't know why I did that. So probably the best way is to take think of it as, I guess I did want to do that, squared, and then cube root. And that's probably as good as you're going to do on number 13. 15 is similar. Let's take a look at that one right below here. So y equals the, so 15 y equals 2 times the fourth root of 9 minus x squared, which I'm going to write in power form. And now we have a product rule. So the first times the derivative of the second. So now we got to do the, we got to do that power rule first. Reduce the power by 1, chain rule, negative 2x. So that's the first times the derivative of the second. I'm going to have to move this whole thing over a little bit. Okay. And now we have to add that to the second times the derivative of the first, which is 0. So this part wipes out. So even when you know that's going to be gone, I don't know, I think it's wise to write it out so you don't forget about it other times. So now let's see what we can do to simplify this. So we've got 2 times negative 2x, which is negative x. We've got a 4 on the bottom. And we've got this thing that goes on the bottom. And yes, you could write that as, I mean, you could write it like this. So that's about as, I would say either one of these answers is correct. I'm guessing the one on the right is the one the book probably leans toward. So did that help?
Yes, thank you.
You're welcome. Any other questions from the 3-4 assignment?
Could you do 27?
Yes. Okay. 7, we'll go back and find it. Oops. Number 27. Okay. So we obviously, what would you say overall, what do we have here? We have a quotient. So we're going to have to use the quotient rule. I mean, actually we could do it that way, or we could rewrite it. So let's think about doing this. So if we wrote it like this, hang on a minute. I don't know what I'm... Okay, so we could think of this as x squared plus 1 to the negative 1/2 power, right? It's a negative because it's from from the denominator, and it's to 1/2 because it's a square root. Now we could do a product rule. And anytime you can reduce a quotient rule to a product rule, it's just a little bit less complex. So now let's try doing our derivative. So we've got the first times the derivative of the second. Reduce power by 1. Chain rule. Yeah, writing a little bit too large here. Got to move it over. So we did the first times the derivative of the second plus the second times the derivative of the first. And the derivative of the first is 1. So that's the execution of the derivative. So now let's try to get this in a form that's, I don't know, a little bit easier to read. So we've got an x times a 2x, which is a 2x squared on the top. And then we've got this negative 1/2. So negative. So that negative 1/2 is going to get rid of that 2. So let's just leave it that way temporarily. Okay, and then you've also got this thing in the bottom, x squared plus 1 to the positive 3/2. That's all on the bottom. And then this other one is just, what? One of these on the bottom. So what can we do here? So this comes down to negative x squared. Down here, let's write this in root form now. That's the square root of x squared plus 1 cubed plus 1 over the square root of x squared plus 1. Yeah, I mean, I suppose we could get a common denominator, but I'm not sure that's, I don't know. I don't know if that's important or not, but we could multiply this bottom one times the square root of x plus 1 squared, and then they would both have a common denominator. You know, we could do top and bottom, and maybe we should do that just to wrap it, just in case. Okay. So if we get a common, so we could let me change colors here. So to get a common denominator, we need to multiply top and bottom by that. We now have a common denominator. Oh, a little bit of a mess. Hang on. So x squared plus 1 cubed. And on top, by the way, what is the square root of x plus 1 squared? It's x plus 1. So negative x plus x, I'm sorry, negative x squared plus x plus 1. So we could, now I guess that's simpler because now we have it in one fraction. Any follow-up questions on that one? There, now you can see the whole thing. Any others that are there? So whoever asked me about number 27, is that clear, or do you need me to talk about any part of it, or?
No, that's good.
You? Are there any other questions we should go through?
$33.
Okay, 33. Okay, so 33. Well, we need to, let's change to black again. So we've got a lot going on here. What's going on the outside? So on the outermost section of this thing, we have something to the second power. So that's what we should be thinking about first. So how does one do that? You use the power rule. And that's to the first power. Okay. Now, obviously, there's stuff going on the inside here. We've got the sum of two things. So we need to take the derivative of x squared plus 3 to the fifth plus x. And that's the derivative of this plus the derivative of this. Okay. So what's the derivative of x squared plus 3 to the fifth? Again, power rule, 5 times x squared plus 3 to the fourth. Okay. Is that derivative done? No, we still have an inner function times 2x. And then plus the derivative of x. So that's pretty much the derivative of that thing. So now, can we simplify this thing? Well, a bit. Let's see. Let's multiply this 2 out. And then 5 times 2x is 10x. Yeah. I don't know. I think that's about, I mean, we could do some more multiplying out, but kind of chasing after the wind. There's not going to be any, we can't factor anything out because we have 3 terms. I'm sorry, we have 2 terms, and there's nothing in common between the first part and the second part. So could I please check my email? I will take a look at it right now. So, question, would the 4 cancel out on the bottom of number 15? Okay, where was 15? Well, first of all, does this handle 33?
Yeah.
Okay, now, see if I can find 15. Where was that? So the question was, does the 4 cancel out on the bottom of number 15 because of the 2 times 2 minus Yeah, you're right, it does. She was pointing out that when you take 2 times 1/4 times negative 2x, that's going to be a negative, and the 4 cancels with the 2 times 2. So you're right, that 4 is gone. Thank you. You are correct. Let me get that erased. Yeah, thank you. Okay, I think that's it for the email. Now I have a request to do number 21. So we're going to take a look at number 21 next. Well, okay, let's move way over here, number 21. Okay, 21. Okay. So we're supposed to take the derivative of this thing. All right. So I mean, we could rewrite that this way. 3x plus 5 to the negative 1/2 power. Whoa. I don't know what happened to that. Negative 1/2. Okay, so does that make sense? All right, now the derivative, power rule. Bring the power down, keep that thing the same, lower the power by 1, and then chain rule. And then, just trying to simplify this, we have a negative 3 over 2, and then we have 3x minus 5 on the bottom to the 3/2, to the positive 3/2, and then you could write that as negative 3 over 2, and on the bottom, square root 3x plus 5 cubed. So that would be number 21. Thanks for the questions. So Rachel, did that clear up number 21? Are there any other questions? So this is kind of strange, but because I had these kind of desperate requests, I'm thinking you guys, it looked like, well, we only went about 25 minutes here, but the other group, it sounds like we might have a full class. So I'm going to say we're not going to move ahead. You can read ahead if you want a little bit. It's a real change. We're going to be doing what's called implicit differentiation, and it might be good just to take a look at it. Implicit differentiation is when, up until now, we've always had y equals something something x when we looked at a function. This is no exception. I mean, y equals, and then there's that 3x, everything is x on the other side. There are times when you cannot solve for y in an algebraic equation. Are you stuck? Can you still differentiate? The answer is yes. And actually, it's not a very difficult lesson. We're going to take a look. Oh, we do have a question. Okay, so anyway, I have got another request for number 103. So we're going to take a look at that. Okay, number 103. So let's see what that. Okay, that should be on the next page. Yeah, actually, I think I have that one. Yeah, I do. Here's number 103. Okay. So the reason, first of all, just a comment. Why this is the natural log of the absolute value of -1 plus sine over 2 plus sine x. Why is the absolute value sign there? Well, if there, all right, what can you take? You cannot take the natural log of a negative number. Why is that? Because e to some power cannot ever equal a negative. No matter what power you put on e, the answer will never be negative. So it's impossible to take the natural log of a negative. So anyway, this assures that it's not going to be negative. All right. So let's see what I did here. So how does one take the derivative of a natural log? Answer, you flip it upside down. You know, it's 1 over x. So that means 1 over this fraction here, which means that fraction gets flipped upside down. So you'll notice that basically right here, so right here, that's just that first fraction flipped upside down. All right, now we start, okay, we got to do the derivative of that, which is a quotient, so we got to use the quotient rule. So here's the denominator right here, times the derivative of the numerator, minus, sorry, I ran out of space here, the numerator times the derivative of the denominator, all over the denominator squared. Now let me talk about so what I did is I took 2 plus sine times 2 plus sine, which it doesn't look like. So anyway, did I do that correctly? Let me just take a look here. So 2 times 2 is 4. Then we got 2 sine x, so that'd be twice, so you get 4 sine x. And then sine x. So it looks like I multiplied this wrong right here. That should be this thing. Okay, so now, I mean, that's it. Now it's just time to simplify. So I multiplied this out, this, you know, this numerator up here, that times that, you know, I multiplied that out and I multiplied that out and then I gathered those together, and there's a couple terms that wipe each other out there. And then just bring things together, and this should be that. Sorry about that. Okay, number 103. Sorry with that, with the changes made there. And when you know you're down to here, there's just nothing else a person can do. So I just, you know, I would just leave it in it. I mean, there's nothing else you can simplify. All right, thank you for doing that one. Oh, I think there might be one more email. One more email. I'm not seeing another email. Got some text messages here. 13 plus 15. The number 13 and 15. Okay, didn't we do one of those? We did 15. Oh yeah, 13 and 15 we did. Okay. That's one of the text messages. $27. Okay, oh no, we did that one. Okay. 101. All right, 101. It's hard for me to gather all these messages together without my phone. Okay, so number 101. Number 101. All right. Grab it. Okay, here's number 101. Once again, we've got the same situation with why is there an absolute value? Because you cannot take the natural log of a negative number. So that's that part of it. So once again, what does one do when you take the derivative of a log? It's the natural log, the derivative of the natural log. Remember how it looks in our, yeah, it's right here. What do you do to take the, here's where it is, right here. Circling it in black, it's equal to 1 over x. All right, so our problem, we got to take the reciprocal of that. Well, when you take the reciprocal of that, you get y. Yeah, let me change colors here. And let's make that a little bit thicker. All right, so y prime equals, flip it upside down, all right, so we've done that. But there's a chain rule, and the chain rule this time involves that quotient. So now we got to follow that with the quotient rule. Okay, the quotient rule says take the denominator times the derivative of the numerator let's see, I'm running out of space here, times the derivative of the numerator, okay, minus the numerator, wait, denominator times derivative of numerator, minus numerator times derivative of denominator. All over denominator squared. All right, so what can we do to work on this? Well, let's multiply out what we've got. So we've got cosine x minus 1 over cosine. Here we have negative cosine sine minus plus, because we have a negative times a negative is a plus, cosine sine over so we've got these two numerators wipe each other out, don't they? So I want to just see if I did that right. numerator, so denominator what did I do? So I flipped it upside down, then I took denominator, yeah, cosine, times derivative of numerator, minus the sine, minus the numerator. Oh, that's supposed to be cosine x minus 1. Okay, I see I made one little error right up here. And that turns out to be, I shouldn't say little, it turns out to be big. So, denominator times derivative of numerator minus numerator. Okay, denominator minus numerator times derivative of denominator. There we go. So now when I multiply this out, it comes out a little bit differently. So let's get that straight. So now when you multiply cosine x times minus the sine of x, that's, yeah, let's leave this minus sign here. I'm going to leave the minus sign as it was, that one right there. And then when you take cosine x times negative sine, you get negative cosine sine. And then negative 1 times negative sine is plus sine. Oh, I got some sloppiness here. Hang on a minute. Can't write quite as quick as I want to do it. So I got to move this over again. So now, when we take negative 1 times negative sine, you get plus sine x. Okay. So now, what happens? Well, this right here is going to be plus because minus a negative is plus. And minus cosine sine plus cosine sine is 0. But you still have left on the top the sine of x. Cosine x minus 1, cosine x. And then this becomes times sine x over cosine x minus 1 squared. And one of these, that one right there, cancels with that one. And you've got left sine x over cosine x and cosine x minus 1. All right, let's go a little bit further. That's the same as sine of x over cosine squared x minus cosine. Yeah, I'm not sure you can go any further than this. I mean, you could multiply that out like I was starting to do here. Cosine squared x minus cosine x. You know, I was thinking this part you could write as the tangent. I'm not sure it helps. You still got this 1 over cosine x minus 1. So I believe that, I don't know, somewhere in there is where I would leave the answer. Sorry, that got to be bigger than I thought. So there's number 101. You could either, I don't know, I would be good with this answer, or with this one on the bottom here. That one. Either one of those two. Okay. Anybody else? Any 3.4 questions? So we're making this a 3.4 fest here, which is fine. I think maybe we were due. This lesson, remember when I first told you about lesson 3.4, I told you it was a three-parter? Well, it's turning out to be a three-parter. It just loaded to watch for now. And wow, hard to keep track of all of it. So 103, did I do 103? Let's see, I can't remember. Did we do 103? So Abby said she got a different, okay, we got all kinds of stuff going on here. Number 101, by separating the natural log into two parts. Oh, so in other words, you wrote the natural log of cosine of x minus the natural log of cosine x minus 1 using log laws. Yeah, that's fine, Abby. That would have saved us a lot of work. Yeah. Thanks. Good thinking. Could anybody tell me, did I do 103? I did. Okay. Thank you. All right. I think we're done. Thanks for your questions. We will start lesson 3.5 on Friday. Do I have my days right? I'm sorry, on Wednesday. Tomorrow, on Wednesday. There we go. Thank you. Thank you, everyone. I appreciate it. Thanks for the good questions.